Don't play with us, man. Now, River Soldier, like I told ya. Let's get started. So, I'm Hamish, but a lot of people sometimes they like to call me Bacteria Diners or now River Soldier, now River Diners. Let's get started. So, we don't want to waste time. We have some questions here, quadratic equations. Let's see how we can solve them. Now, let me start with these so I can have a space. Now, they say the graph of the equation. So, first and foremost, this is quadratic already, we know, because the highest degree of x is 2. It's 2. So now they say here, so they give us quadratic and they give option 1, 2, 3, and 4. So the option is more of the does not cut at x-axis, cut at x-axis, cut at x-axis, or where. So we want to see which is going to be correct. So it's more of like find the x-intercept. But we know for facts, if I have a graph, so first and foremost, excuse me, I have to take this graph here. So y equal to negative 4 x squared plus 8 x minus 3. So what is my a? My a, this number here, the one with the x squared. What is my b? My b, the one with only one x. It's like say a x squared plus b x plus c. So this is my b, this is my a. So my a is equal to negative 4 and my b equal to positive 80 and my c sometimes we call y-intercept equal to negative 3. So now the one where is going to cut at x means these are x-intercept. So we have a formula of finding the x-intercept. When x-intercept y equal to 0. When x-intercept y equal to 0. So if I want to get x-intercept, I have to apply my formula. Easy. So formula of x-intercept equal to negative b plus or minus, and they say b squared minus 4ac over 2a. So this let me see, we have a negative bracket b. Put your bracket b. What is a b? Positive 8. Plus or minus square root. B square means 8 square. It's very good to put bracket. 4 times 8 times c. A, what is a? A equal to negative 4. Negative 4 times c. What is a c? C equal to negative 3. So this c equal to negative 3. So here times negative 3. I'll just erase this. Negative 3. Negative 3. Over. You see line start from here. So you say over, some people sometimes they draw from here, that's very wrong. Don't do here, you'll be chopped out. From beginning, okay? Over 2 times a, what is my a? A equal to negative 4. So now for that case, I can plug this in the calculator so I can just wait here to have some space. Let's go quick, and then we can go to the option and see which option is correct. Okay, cool. So now this must be all the way. So this let me say negative 8 is going to be negative 8 plus or minus, and then we have a square root. Now 8 squared equal to 64 minus. Okay, look, minus 4 times minus 4, positive 16. Positive 16 times negative 3 is going to be negative 84. Negative 480, excuse me. Negative 480, and then we over 2 times this called negative 80. Oh, so we can just simplify further. This let me say we have a negative 80 plus or minus, this is 64 minus 480 equal to 16 square root over negative 80. But if you have a calculator, you can plug it in once off and then you go, you save time. You know what I'm saying? Okay, so that's going to give us our x equal to, the first one is going to be negative 80 plus or minus square root of 16 equal to 4. And this equal to 4 and then divided by negative 8. So either the first x, because you got plus or minus, let's start first with a plus. The first x is going to be negative 8 plus 4 equal to negative 4. So this is going to be negative 4 over negative 8, or negative 80 minus 4 equal to negative 12, or x equal to negative 12, but over negative 80. So for that case, this is going to be positive a half. So the first value of x, positive a half. So we can see something here. So something that this possibly could be our answer, but let's go. Or now we come here, negative, positive, so we have a 12, this and this positive, equal positive 12 over 8. Okay, so if you divide this by 4, 4 is the common number. How many 4 in 12? There are 3. How many 4 in 80 there? 2, so 3 over 2. So x equal to 3 over 2. But what 3 over 2? How many 2 in 3? 1, 2 in 3, and they'll be left with 1 over 2. So half or 1.5. So this is going to be our option, option 2. So these are x-intercept. You know what I'm saying? X-intercept equal to half and negative half. So option number 2. Now let's go to question number 3. Because that's what it asks us. You know what I'm saying? So now let's erase and then go to question number 2. Make a space. What you gonna do? What you gonna do? Oh, what you gonna do? Okay. So the question is done. So maybe I can just continue for fun, you know, for you to understand, because, you know, because the important thing is to understand. It's not just to answer that question and it's like I'm done. Let's find, so we know it's x n, x equal to a half n, and 1.5. And then we can draw a graph of that, okay. So X intercept, excuse me, just a next second. Okay, so X intercept for this question equal to a half and X intercept equal to 1.5. Let's find Y-intercept. Y-intercept is this value here. Y-intercept, Y-intercept, or you can say C equal to -3. Now, let's find the turning point. Turning point is easy to get. Turning points, I'm going to say X a turning point, or sometimes this we call axis of symmetry. X a turning point is axis of symmetry. Axis of symmetry. Axis of symmetry. Axis of symmetry. I can get it. We have a formula (b/2a) to get x a turning point. You know what I'm saying? Like I told you, sometimes if you forgot this formula, there's an easy way for you to remember. Just remember, go to the formula sheet if they give a formula. If you're not, then make sure you memorize. Most of the time I encourage you memorize. You have the formula of (b) plus or minus b squared minus 4ac over 2a. So if you forgot an exam, this is what you take. (b/2a). You know what I'm saying? And this is going to give you turning point. So all axes of symmetry. (b). What is a b? B is this number here, the one with 1x. Positive 8 over 2 times a. What is a? A equal to -4. So now this will be negative positive -80 over, this will be -8 equal to positive 1. 1. So x at turning point equal to 1. Sometimes there's another way how to get x at turning points. Only if you have your x intercepts. So how you do that? So if only if you already have your x intercept, but I will encourage you to use it if you don't have x intercept. For this case, I have my x intercept. So what I'm going to do, take your x intercept, add them by 2, divide by 2. Look, it must give us that. Look, so we're going to say x at turning point. Another method, take this x at intercept plus another x intercept, 1.5, and then divide by 2. Okay, a half plus 1.5 equal 2. 2 over 2 equal to 1, which is the same as 1. You know what I'm saying? Oh yeah, equal to 1. So that's another way. Only if you have an x-intercept of intercept of the quadratic equation. You know why? Because look, let me explain to you quick. Okay, if I have a graph like this, so if I want to get this point, it means it must be this and this, add them, divide by 2. That's why we take the x-intercept, add them, divide by 2, is going to give us x at turning point, or axis of symmetry. You know what I'm saying? So that's how we get. So now, let's move. So we have x at turning point. So now let's find y at turning point. So y at turning point. Okay, you see this quadratic? Say y at turning point, and then equal to -4. Take this x at turning point, substitute in here. So it's going to be bracket. Take this in there. So it's going to be 1. Whatever you get here, in there to get y at turning point. We take x at turning point, substitute in a graph square, and then plus a 1, and then -3. And this is going to give us 1 squared is 1, it's -4, so it's going to be -4, and then plus 8, and then -3. And this is going to give us 1, positive 1. Oh, y turning point equal to positive 1. So a turning point, or vertex, x equal to 1 and y equal to 1. So sometimes we call it turning point, sometimes we can call it vertex, sometimes we can call stationary point. So turning point, sometimes we can call it vertex, or sometimes we can call stationary point, or turning point. It's the same thing, you know what I'm saying? For this case, okay, is vertex. For this case, vertex, you know what I'm saying? Means where the graph turns. It's where vertex. Okay, cool. So we have all the turning points and everything, so we can draw the graph right now. You know what I'm saying? Let's draw the graph. So the row graph is very easy. First and foremost, I need to know this graph is going to concave upward or downward. Before the drawing, I can figure where is this curve. Okay, cool. So this one here, when you're A, you see this is A. My A is less than 0. So if it's less than 0, the graph is going to concave downward. The parabola is going to only if it's less than, because A equal to -4. We know -4 is less than 0. So before even drawing, I know it's going to concave downward. So this is telling me the parabolic or how the graph is going to turn. Here we go. So now let's draw the graph. My intercept is 1/2 and 1.5. So it's going to be like this. And it's going to be half. Let's say this is 1. Let's say this is 2. So half is going to be here. 1.5 is going to be this. Let's say 1. 1.5 is going to be somewhere here. 1.5. So turning point. We know turning point. Okay, y-intercept -3. -1, -2, -3. Let's say this is -3. So this graph is going to go like this. Turning points or turning points. 1, 1 means let's say this is 1 and 1 somewhere here. So we know this graph is going to concave downward. You know why? Because this A is less than 0. So, and here is going to turn at the vertex. So this is a turning point, which is 1, 1. And this is a 1.5, and this is -3. Now we got. So this, make sure when you finish, you must allocate to say this is the graph of equation y equal to -x squared, and then plus 6x, and then plus 7. You're done. Know what I'm saying? You're done with your equation, okay? We have the vertex, you have the turning points, or you can call section of the point, etc. We're done. Let's go to question number 2, okay? Question number 2. Here we go. Here we go now. I'm putting some water just a second. Okay. I drink a lot of water, man. A lot. Let's just see. Energy, man. Okay, cool. Let's go. Energetic, man. Bring the energy. Here we go. Oh my God. Now we were soldier. Okay, cool. Let's go. So now, question number 2, number 3. Let's say we got the graph. So we know this graph is going to concave downward because A is less than, A is negative. So this graph is going to concave downward. Now let's say we know this is equal to this. So they're kind of trying to confuse you, you know. But don't get confused, don't get shaky, don't get it twisted. You know how we do. So this is the same thing. It's like they're giving standard equation of quadratic. So I say, oh, okay. So what do I want? What do they want? What do they want? What do they want, these people? Let's go. Okay. So let's say this equal to that one. It's like saying y equal to -x squared plus 6x and then plus 7. And it's like writing this under, like say ax squared plus bx plus c. So if you know your math, it's like, you know what? It's like, you know. So so we know a equal to -1 because there's no 1 here means negative. Somebody say negative means if there's no number here, means there's a 1 here. So a equal to -1, b equal to positive 6, and now c equal to 7. C equal to 7. So you have a, b, and c. We got all of them. A, b, and c equal to 7. C equal to 7. C equal to 7. Now what do they want? Let's say this graph, which is this, has a maximum turning point. What I mean turning point maximum before? Let me explain to you. Look, we know this graph is going to concave downward like this. So if this graph is going to come, this is not like actual graph roughly. Let's say this graph turn like this. So this is a turning point. So is it on top or is at the bottom? It's maximum turning point. You know what I'm saying? It's maximum vertex or section of the points because you can see it's on top. And why is concave like this? Because this value is negative. So it's going to concave or downward. So the turning points or section of the points or maximum value of turning point, you see, is maximum. That's what's on top. But if your graph concave downward, and this must be stuff like, let's say 3x squared plus 7x, let's say roughly. So this is bigger, greater than 0. So the graph is going to concave downward. Concave upward, my apologies, I may say upward. So what that means your turning point is going to be minimum turning point. Minimum turning point. Because look, is at the bottom, but this maximum turning point, so the graph concave downward. Because this is minimum at the bottom, this maximum at the top. So, okay, now let's say here, but what that determine the graph like this? Something will determine whether the turning point is on top or bottom is this A. Either A is greater than 0 or less than 0. So for this case here, they say the graph of this, so we know this is going to concave downward because A is less than 0 for this case. So for this case, A is less than 0. Or in other way, we can say A equal to -1. -1 is less than 0. That's to say A equal to -1. Has a maximum turning point. Why has a maximum turning point? Because it's going to concave downward. Like I said, this is a rough sketch. So it's going to concave downward because A less than 0. And then how they say? What that causes? Because this A is less than 0. Because A equal to -1 is something which makes this concave downward. And that's give us the maximum turning point. So option 1 is correct. But if this was positive, and then we know for effects, okay, for example, so option 1 is correct. Okay, so if this A, let's say let's say it was positive here. Let's say positive x squared and then plus 6. You give me the number. Let's say 8x. Okay. Now let's do something like this. Let's say 4x minus 7 minus x squared. So this phase we need to rearrange in a standard equation of a quadratic. You know what I'm saying? So parabolic is standard equation for quadratic is standard equation of quadratic or parabolic. So this is gonna have to start phase. So remember, when you never check a number, you must check with each sign. So it's gonna be negative x squared, and then it's gonna be plus 4x minus 7. So we see this A still less than 0 because there's a 1 here, even if they didn't give us, but there's a 1. So for that case, this graph is gonna concave downward because this A is less than 0. So for that case, roughly, let's say it's like this. So this is turning point. So what that determines the concavity or maximum or minimum of the so for this case, turning point is on top, so it's maximum. So what that determines this is this A is less than 0. But if in a case, let's say it was 3 or any number, let's say plus or even plus or 3, let's say 3. So I could have to rearrange, means this 3 is going to come here, which is going to give us because this must start here, it's going to be 3x squared. And then means A now is greater than 0 because it's positive. So I'll just put here first. Okay, let me say this so that I don't confuse you. So let's say stuff like this. So I have to rearrange in the standard equation of a quadratic. So this is going to be 3x squared and then plus 4x minus. Oh, so A is greater than 0. So for that case, this graph is going to concave upward. So means, let's say roughly, I don't know the X intercept, Y-intercept, this is roughly, okay? So means this is the minimum turning point. Minimum TP turning point. So sometimes we can call it vertex or stationary point. Why we call stationary point? Because if I have a ball or egg or orange, if I put anywhere here, it's gonna fall. But here it's gonna be stationary. Same even with something. See, that's the only position where the ball can sit. Never mind my right. You know what I'm saying? So now that's how you do. So for that case, because that's the answer. What about this one? No, this one is not true because A is not greater than 0. B, no, B does not determine anything. C has nothing to do because somebody can have like this. For example, if you say C did, don't worry about that, man. It don't make sense. It's like, oh, why you don't make sense? Okay, for example, somebody can have a graph like this. This is C, let's say in positive 4. This that does not determine, this is Y-intercept C, does not determine whether something maximum minimum. You know what I'm saying? Okay, this does not determine. because it could be same number, but the graph can be like this. So this does not determine either maximum or minimum. Okay, so we're done with it, but we can just do tandem planes graph and draw the graph. Okay, so you get to understand more. Okay, now let's draw a graph and get X intercept and everything. Oh, the same question. Cool. We're almost finished, guys. Okay, cool. There we go. So now, first and foremost, let's get X intercept. So we know this A is less than 0, so means less than 0 means A. That to say A. Oh, so wait, sorry. That's to say the A is -1 for this case, so it's less than 0. So now let's find X intercept. When X intercept, Y equals to 0. So when X intercept, Y equals to 0. How are we going to get X intercept? X equal to our formula, -b plus or minus square root of b squared minus 4ac. Please memorize this. You can memorize this in 2 minutes. I memorized this when I was grade 7 or grade 8. Grade 8, I have to be honest. In 20 minutes, and then start to recite all the time. Like recite it all the time. -b plus or minus blah, 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 minus plus or minus b squared minus 4ac over 2a. Okay, so start from here. Your line must start from here. Some people sometimes they make mistake and they put it here. You're gonna be in trouble. This line must come all the way to close to equal sign. Okay, what is our A? Our A equal to, there's no number, -1. What is our B? Our B equal to this number here, which is positive 6, and our C equal to this number here is positive 7. But it must be in the standard equation of a quadratic. So for that case, now we substitute. Say X intercept equal to negative. What is a B? B equal to positive 6 plus or minus and then square root. B squared means positive 6 square. Make sure you put this bracket, it's going to help you. A, what is A? A equal to -1 times C. C, what is a C? C equals 7. And then we over 2 times A. What is A? A equal to -1. So now we're going to say this is equal to -6 plus or minus. This is going to be 36. And this is going to be negative positive 4. 4 times 7, 28. 280 plus 36. 28 or 4, 6, 4, 6 or 4. So this is going to be plus or minus square root of 60, 4 over -2. So this is going to be -6 plus or minus square root of 64 equal to 80 over -2. And this is going to give us -4. So we have a 2 value of x. Our x equal to -4 plus 80, -6 plus 80 over -2. Or our another x equal to -6 minus 80, means minus 80 over -2. So now x, the first x, our x equal to -6, and this is going to be positive 2 equal to -1, because it's going to be -6 plus 8 equal to positive 2 over -2 equal to -1, or another x equal to, okay, this is going to be -14 over -2 equal to positive 7. Oh, so we have an x intercept equal to what we got over there. Okay, so this is what we got. So this is an x intercept. Okay, so in other words, you can say when x equals -1, y equals to 0, and when x equals 7, y equals to 0. So we got x intercept. For y-intercept, this is y-intercept, but only when it's in the standard equation of a line. So now, oh, okay, so we're going to say when y-intercept, x equals to 0. So in other way, this same as C. What is y-intercept equal to? 7. So I have y-intercept, x-intercept. Now let's get to the tandem plane. So I can just make a space here. Tandem planes quick. Oh, let me write all these data here. So x-intercept, so we have a space. X-intercept, -1 and 0. Or you can just say -1 or say -1 and 0. And another one is what? 7 and 0. Okay, y-intercept or y-intercept, excuse me, x always equal to 0. And then what is a y-intercept? 7 says C, which equal to 7. Okay, tandem planes now. Let's make a space quick. Let's get tandem plane face and then we're going to make a space. So tandem planes, x a tandem plane, or sometimes how we call this, this is called line of symmetry. Line of symmetry. How we get this? This equal to -b over 2a. Negative. What is a b? B equal to, let's go, positive 6 over 2 times a. A equal to -1. Okay, negative 6. So this is going to be negative 6 over negative 2 because 2 times negative 1, negative 1. 2 times negative 1, negative 2. And this negative negative positive. 6 over 2 equal to 3. Oh, x at turning point equal to? So turning point, our x equal to 3. Now we want to get what? Y at turning points. We don't know here. That's fine. So y at turning points means what I'm going to do, I'll take this x at turning point and substitute in the original equation. What is it? Here. In the position of x. Okay, so let's make a space quick because space is not enough now. So let's get y at turning point here quick and then we can draw a graph quick. Okay. Okay, cool. So y turning point equal to negative, negative. It's like negative 1 bracket x. What is the x? X equals positive 3 square and then plus 6. What is the x? X equal to positive 3 and then plus 7. So this is going to give us, we have a negative 3 square equal to 9 and then plus 18. 6 times 3 equal to 18 plus 7. This and this is going to be 25 minus 9 equals 16. Equals 16. Oh, so our y turning point equal to 16. So our turning point x equal to 3 and y equal to 16. Oh, turning point x equal to 3 and y equal to 16. Cool. So we got x intercept, y intercept, and turning points, which is the vertex or stationary points. So what we can do then, we can draw our graph because we have all the information. Let's draw now. So now I'm gonna make a space quick and draw a graph and we go. So we know this graph is gonna concave. How is it gonna concave? Guess for me. How? Oh, it's gonna concave downward because this a is less than 0. A is less than 0. Okay, cool. Now we go. So now it's going to concave downward. We know concavity is going to concave what? Concave what? Downward. Why? Because A is less than 0. So A less than 0, so now we can see that to say A equal to negative 1. Okay, now let's draw a graph. So x intercept equal to negative 1 and 7. So this graph is more to the right. Negative 1 and 7. So negative 1, let's say this negative 1, and 7, let's say here 7. This is a rough sketch, never mind. Turning point 3 and 16. 3 and 16 means 3 and 16. X equal to 3, let's say somewhere here, 16, let's say somewhere here. This is a rough sketch, guys, right? So 3 and 16, okay. Turning point, a y-intercept, 7. Oh, exactly, we got it. Turn here. Done. We cut to x-intercept, which is negative 1 and 0, or you can just say negative 1, and this is going to be 7 and 0, and this is 7, means 0 and 7 another way. Or you can just say 7 here. That's how you draw, and this is our turning point, or you can say vertex, or you can say stationary points for this case. So when you finish, make sure you allocate me. This graph is for which equation? Negative x squared plus 6x plus 7. So you're done. Now let's go for the face equation that we know we're done with this business, okay? Let's go to the face equation, guys. Let's go. This is a crash course. We finish all this stuff, man. Okay, cool. So then you'll be fine and you get a distinction. Okay. Okay, question number 1 is easy. I'm not even supposed to do this question because it's walk in the park, baby. Okay. Okay, cool. Let's whack. Let's go. So we got it. Okay, now what do the want? Same game, same story. Same game, same story. So I give a question here. The question say, a axis of symmetry Oh, we know how to get axial symmetry. We do know, baby. Axial symmetry means is x at tangent plane. So, an axial symmetry of the graph of the function is at, I know axial symmetry. Axial symmetry means if I have a graph like this, means these are tangent planes, means it's axial symmetry. Because it's just like x at tangent point in that. That's the axial symmetry. So we can get, so axial symmetry for they say is at, so equal to negative b over 2a. So negative, what is a b? B equal to the one with x, negative 80 over 2 times a equals 4, so negative positive 80, and this is going to be equal to 80 equal to 1. So axial symmetry is at 1. Symmetry is x equal to 1, or you can say x at tangent point. This is x at tangent point equal to 1. Okay, now find the vertex. Okay, so if you want to get vertex, if you have an x at tangent points, means we can get y at tangent points. How are we going to do that? Take x at tangent point, substitute in the original equation. So I'm going to say, so y at tangent point equal to 4, and then here I'm going to put x at tangent points, which is equal to 1 square, and then minus 8x, x equal to 1, and then we plus 3. So this is going to give 1 square, start with this one. From the bottom, as you must start with the bracket. So 1 square equal to 1 times 4 equal to 4. Minus 80, and then plus 3. This and this is going to give us 7, negative 1. So negative 1. So y at tangent point equal to negative 1. So we can write here our tangent point equal to 1 and negative 1. You know what I'm saying? And how this is going to concave, the graph is going to concave upward. They didn't ask, but I'm just doing for the fun. Concavity. What about concavity? Concavity is going to be what? Upward. Why? Because our a is greater than 0. Our a equal to 4. That means a is greater than 0. Excuse me. So we got the tangent point, stationary point vertex, the same thing for quadratic. Now we want to go for X intercept. X intercept, we know how we use our formula. Let's make a space quick. Let's use our formula quick. And get this X at X intercept and Y intercept. Okay, cool. So this one I think is already the answer already. If the graph has a maximum or minimum. So how this graph is going to concave before I do the tangent point? This graph is going to concave. Look, this graph is is positive here. So we know this graph is going to go like this, roughly. So we're going to have a minimum tangent point. You know what I'm saying? The graph has a minimum or maximum value. But we know it has a minimum value. Means the tangent point is going to be under here. Why? Because it's going to concave upward because a is greater than 0. So this graph is going to have a minimum value. It's going to have a minimum value. Minimum value, or we can call tangent point, we can call stationary point. Stationary point, which equal, what is the stationary point for this case? 1 and negative 1. Okay, so this will be answered already. Now let's go for the second one. Find the tangent points. We did find the X intercept. We know how to use the formula X intercept. X equal to negative b plus or minus. That's going to give us X intercept. B squared minus 4 AC over 2a. So X equal to negative. What is a b? B equal to negative 8 plus or minus square root of b, negative 8 square minus 4 times a. What is a? A equal to 4 times c equal to 3. Over 2 times a. What is a? A equal to 4. So x. Okay, this 64 and this this and this 16 for 8, because this and this 16 times this equal to 48, and this is equal to negative 8. Negative 8 times negative 8, 64. When your minus is going to give you 16 square root. So negative 80 plus or minus square root of 16 over 8. So this is going to be negative 80 plus over square root of 16 equals 4 over 80. Now we can say we got two values of x. The first value of x equal to negative 8 plus 4 equal to negative 4 over 18. So negative 4 over 8 equal to negative a half. Or this is going to be negative 8 minus negative 4. Negative 12 over 8, which is how many 4? The common number is 4. How many 4 in 12 equal to 3, but there's negative, and how many 4 in 8 equal to 2. So this is like saying negative 1.5, and this x equal to negative a half. Oh, so these are x-intercept. You know what I'm saying? X-intercept, you got negative a half and negative 1.5, or negative 3 over 2. So now we're going to say our x-intercept. Oh, we're going to write. So our x-intercept, okay, negative a half and negative, okay, negative 0.5. Negative and negative 1.5. Okay, let's make some space here. So x-intercept, when x-intercept y equals to 0. And what is the x-intercept definition? Is negative a half or negative 0.5, or you can say negative a half, whatever you're going to say. And another one, when you know when x-intercept y equals to 0, which equal to negative 3 over 2 is like negative 1.5. And this you can say negative 0.5 if you want. Whatever you want to say. So this is the same thing as this one. Okay, cool. So now we got it. And this means this and this one. Okay, so now we got x-intercept or y-intercept. Y-intercept, we know this, the one with no x. So y-intercept, or you can say c, equal to 3. So now we have everything. We have the turning point, x-intercept, y-intercept, so we can draw the graph. Let's draw the graph. And we will be done. Yeah, y-intercept we got. Oh, it's going to be slope and draw a graph. Okay, slope, we're going to get it. So the last one is going to be slope. We finished, baby. Okay, now let's draw a graph now. So x-intercept equal to negative a half and negative 1.5. So everything is on the left, roughly. I think it's going to be like this, because our x-intercept is more to the left. Negative a half and negative 1.5 is like if this negative 1, this negative 2. Let's assume negative 2 and this negative 1 means negative 1.5 is going to be here. Negative 1, 5. Or you can see, yeah, 1.5. Okay, y-intercept equal to 3. Y-intercept equal to 3. Yeah, 3. Let's say 1, 2, 3 here somewhere. Turning points or turning points equal to 1 and negative 1. It cannot be 1 and negative 1. You know what I'm saying? I mean, turning point cannot be here. Turning point has to be here. So either I made a mistake with the x-intercept or I made a mistake with the turning points. Let me repeat my x-intercept. I think I made a mistake with the x-intercept. Quick. Again. Okay, so my x-intercept might be wrong. I think so. I think this is the second time I'm doing this mistake. Same question. So negative, so we say negative b plus or minus b squared minus 4 ac over 2a. So equal to x equal to negative. What is a b? B equal to negative 8. Negative 8. I think that's how I make mistake. Plus or minus b squared. What is a b squared? B squared. B squared, what is a b? Negative 8, negative 8 is equal to 64 minus 4 times a equal to 4 times c equal to 3. Make sure you write all the way from here, equal sign, all the way 2 times a equal to 4, x equal to. So x is turning point, 80 plus or minus, this is going to be 64, 64 minus 48 equal to 16. And this is equal to 8. Okay, 80 plus or minus square root of 16 equal to 4 over 8. Okay, so x equal to 12 over 8, so 12 over 8. Or 8 minus 4 equals 4 over, so it's going to be 4 over 8. So 8 equal to half, this equal to half, and this equal to 3 over 2. It's like a 1,5. So this is positive here. What is that? Okay, so this was wrong here. My apologies. Apologize. So x equal to a half, and another x equal to 1.5 or 3/2. So now if you have to draw a graph, so we know this graph is going to be to the right because x intercept a half and 1.5. Okay, so it's going to be stuff like this, more on the right. A half, let's say this is 1, let's say this is 2, a half is going to be somewhere here. And 1.5, this is 1, let's say this is 2. So 1.5 is going to be somewhere here, or 1.5. And this is a half for 0.5. Okay, so you say 0.5 or 0.5 half. Now, y-intercept equal to 3. 1, 2, 3, somewhere here, let's say. Turning point is 1 and -1, means if this is 1 and -1 is going to be somewhere here, they made up here. 1 and -1. So we know this is going to concave upward because this is greater than 0. So the graph is going to come like this. It has to make sense. And draw your arrow. So we're done. So after that, make sure you allocate. Say this graph of that equation, y equal to 4x squared minus 8x plus 3. And you're done. You know what I'm saying? So now the last thing they say, find the graph already drawn, find the slope of gradient. To find the slope of gradient, what you do, you differentiate. You know what I'm saying? So how you going to differentiate? Let's find the slope of gradient. And this is going to be the end of a quadratic. We're done with the all quadratic, baby. Okay, cool. So to get a slope or turning point, this is what you do. Slope means like face derivative of what you have. So this is how you derivate. You know what I'm saying? Slope in other words, say this is a face derivative, y dash. So how you get y dash? Look. So I have my equation, which is 4x squared and then minus 8x. So since there's no power, means power 1. You know what I'm saying? If I say 3, 3 is like say 3 power 1. Means 3 power 1 equals 3. So you say x power 1 plus 3. Now let's get the gradient. So now when you derivate, this is going to be y prime, now you derivate, equal, take this number here, multiply by the number at the back, 2 times 4 equal to 80, drop the way how it is, your x, drop it down, take whatever is here on top, minus 1, 2 minus 1 equal to 1, minus, now do the same game here, take this number, multiply by whatever is here at the back, 1 times negative 80, drop your x, 1 minus 1 equal to 0. But this one, it does not have an x. So when you derivate equal to 0, so this is going to be 0. Only this with the x is going to be certain number. But since this doesn't have an x, it's going to be 0. So now, this meaning gradient. So gradient equal to 8. X power 1 is like x minus any number power 0 equal to 1. So it's going to be 80 times 1 equal to 8. So this is our gradient. You know what I'm saying? That's going to be our gradient. Okay? That's our gradient. So in exam, only if they ask gradient at a certain point, and then you can just do your thing. But for this case, this is our gradient equal to that one, 8x minus 8. But if they say gradient at, for example, at this point, for example, gradient, I'm just saying, for example. Excuse me. No, I'm wrong. I gotta say something here. So these are gradient here. Okay? But sometimes, no, I don't want to go far. That's another thing. We're going to do that one in calculus. So that's a gradient, but I must say gradient at, let's say, x equal to 1. So what I'm going to do, I'm going to take this x and put in here. So my gradient equal to 80. I want to put here the value of x equal to 1 and then minus 80. 80 minus 8 equal to 0. So when x equal to 1, because which will make sense for now. You know what I'm saying? Don't worry about it. It's not part of the question. This is what you want. But that's another thing I'll show you now. Topic calculus. How to get turning point using derivative. Using derivative. Using derivative. soldier, ow. I'm out here.